Okay, in today's lesson we're going to be looking at lesson 2.9, dealing with combined and joint variation. We'll learn about what the difference is between these two here in a little bit. But first off, let's look at the definition there. It says a combined variation equation has two or more independent variables, and the independent variables can have any positive exponent. To find k in a combined variation model, use the same strategy as in a variation problem with one independent variable. And we're going to follow these steps. But basically, combined variation, to put it in my own words, takes and does exactly what it sounds. We're going to combine direct variation and inverse variation into one problem. Now, we were actually doing this in the previous lesson. In the previous lesson, we looked at data and set up direct variation problems or inverse variation problems for each individual scenario. And then we took at the end and combined them all into one variation problem. Well, in today's lesson, they're going to have all the information set up for us, so we don't have to figure out if it's direct variation individually or inverse variation individually. It's going to give us all. It's going to set it all up in one problem, and so we just need to basically do the work and answer the question. So the 4 steps that we did at the beginning of the quarter or the beginning of the chapter is going to be the same 4 steps that we're going to use now. It's just that when we set up our general equation, it's going to have more than one variable in it. So again, those 4 steps are that we're going to write a general equation. Then and that general equation is going to have k in it. We're not going to know the value of k at that point. The next step then is to figure out what k is. Well, just like before, they're going to give us numbers that we plug in and use that information to solve for k. Once we know what k is, now we can write a specific formula, or what sometimes they'll call a variation equation or variation formula. And we can use that formula then to answer the question that they're asking us to find. So let's look at an example here. It says Mario is pedaling a bike at 80 revolutions per minute using a front gear with 35 teeth and a back gear with 15 teeth. At these settings, he's traveling 14.5 miles per hour. Use a combined variation equation. Okay, so in this situation, they give us the combined variation equation where S represents the speed of the bicycle, R is the revolutions per minute, and F is the number of teeth on the front gear, B the number of teeth on the back gear. So you want to use that to describe how his speed would change if he increased his pedaling to 100 RPMs. Well, okay, so we already know our general equation. Remember to keep your work organized just like we did before. So now that we know our general equation, now what I want to do is I want to figure out, well, what's k? Well, in order to find out what k is, I need to know a value for r, f, b, and s. Well, let's look at the beginning here. It says Mario's pedaling a bike at 80 revolutions per minute. Well, that represents your r. Using a front gear with 35 teeth. Okay, that's your value for f. And a back gear with 15 teeth. That's your value for b. At these settings, he's traveling 14.5 miles an hour. And there's your speed. So we're going to plug these numbers into my general equation, and I'm going to use that information to solve for s. So what I want to do is I want to put, again, 14.5, that's my value for s. I'm going to say 14.5 equals my k, and then it's going to be times my r times my f, so r is 80, my f is 35, divided by my b, which is 15. Now there's a lot of different ways that we could solve this problem. So I'm just going to show you what I would do to solve it. One thing that I would do is I would simplify the numerator by taking 80 times 35. When you do that, we get 14.5 equals k times 80 times 35 is 2,800. All divided by 15. Now if I multiply both sides by 15, because I want to get rid of that fraction, or you can think of it as cross-multiplying. Either way you look at it, you get rid of the 15 from the right. And on the left, 15 times 14.5 gives me 217.5 equals, I'm just going to write it like this, 2,800k. Divide both sides by 2,800 to get the k by itself. And now I have k equals 0.0777. It keeps going, but remember, when we're solving these, we want to make sure that if I'm not at the end of the problem, which I'm not, I've just found out what k is, I don't want to round real close to the decimal. So I don't want to write this as 0.1 or 0.08 because doing so would result in having a less accurate final answer. Okay, so I'm done with step 2. I found out what k is. Now I'm going to write a specific variation formula. So for that, it's going to be S equals my k, which is 0.0777 times R times F, all divided by B. Now the question says we want to use that formula to figure out how his speed would change if he increases pedaling to 100 RPMs. Well, that's your value for R. Okay, his revolutions per minute. Everything else is going to stay the same though, because they say all he's increasing is his pedaling speed. So he's using the same bike, so his front gear teeth and his back gear teeth are going to remain the same. So to answer the question, we would say 0.0777 times 100 times our front gear teeth, which was 35. All that divided by our back gear teeth, which was 15. If you do that on your calculator, we get 18.1 miles per hour. So his speed would have gone from 14.5 miles per hour to 18.1 miles per hour. Okay, why don't you guys take a minute and see if you can't solve this one. You're using the same general equation, that S equals K times R times F, all divided by B. So why don't you guys take a minute to see if you can solve that. So why don't you go ahead and press pause and hit play when you're ready to check your answer. Okay, so here's what you should have done. You should have taken and plugged in our information here with our speed being 21 miles per hour equals K times 85 times 39, all divided by 13. If I simplified the numerator, I'd have K times 3,315. Oops. All divided by 13. Multiply both sides by 13. That gives me 273 equals, right like this, 3,315 times K. Divide both sides by 3,315. Gives me a value K of 0.082 approximately. Okay, so then you should have came up with a general equation. So now we can use that to figure out how this girl's speed would change if she decreased her pedaling to 60 RPMs. So now we're going from 85 to 60, so our answer would be 0.082 times 60 times, her bike is going to remain the same, so it's going to be 39 front gear teeth, 13 back gear teeth. Do the math on your calculator and you get about 14.8 or 15 miles per hour. Okay, if you don't have my notes, you don't have to worry about copying all this down. This is just talking about a scenario in the real world, another situation where we would be dealing with combined variation. So I'll just read this. If it says, photographers are always looking for ways to make their pictures sharper. One way is to focus the lens at the hyperfocal distance. Focusing the lens at this distance will produce a photograph with a maximum number of objects in focus. So if you notice with this first diagram over here, the only thing that's really in focus is this tree that's in the front, and maybe part of this tree that's also in the front. The stuff in the back is very blurry. Photographers often use the hyperfocal distance when taking pictures of landscapes. Two images at the right were shot with the same camera at the same settings, except the one on the bottom was taken with the lens focused at the hyperfocal distance, giving the extra degree of sharpness. So you can see at the bottom here that there's more things in the back that are a little bit more clear than what we're looking at in the front picture. Okay, so how does that work out? Well, it says the hyperfocal length in meters varies directly with the square of the focal length of the camera lens in millimeters, and inversely with the selected aperture f. By the way, the aperture is a setting that tells you how wide the lens opening is on a camera. So that's not used in our formula, but it says write a general variation equation to model the situation. So this is going through the 4 steps that we talked about in the front. It's just taking us through step by step here. So the first step, write a general variation equation. It says, so the hyperfocal length, so the h, varies directly with the square of the focal length, so it'd be k times L squared, and inversely with the selected aperture. Now I already have my value, or I already have my letter k in there, so I'm not going to put k in again, but it would be k divided by f. Now it's instead of just being k divided by f, we're going to have k times L squared, that whole thing in the numerator divided by f. So here's our general equation. So now they're going to give us some data, so that way we can figure out what k is. That's part B. So it says we're going to find k when h is 10.42 when using a 50 millimeter lens. That's your value for L. And the aperture f is set at 8. So we're going to plug these numbers in. So it's going to be 10.42 equals k times my L squared. Don't forget to apply the exponent. That's a common mistake that you'll see people make. So don't forget to apply the exponent, and divide by 8. So now what we're going to do is to find out what k is, we're going to have to do the math. So one thing we could do is simplify the numerator. That's going to be 10.42 equals 50 squared is going to be 2,500. Multiply both sides by 8. So I can get the right side without a fraction. That gives me 83.36. All right, like this. And next, divide both sides by 2,500 to get k by itself. So now I got a value of k, which is 0.033 repeating. Again, we won't round it real close to the decimal. You can leave it like that. So now it says write a variation formula for the situation. Now, when I say that again, a variation formula is referring to a specific formula. So make sure that if on a quiz or test, if you were to write this down as your answer, that would be wrong. We want to write our equation using k. So it's going to be h equals 0.0333 times L squared. Again, don't forget the square, all divided by f. So now I can use that equation to answer the question. Find the hyperfocal length needed if you want to shoot with a 300 millimeter lens at an aperture setting of 2.8. So now what we're going to do is we're going to plug these numbers in. So it'll be h equals 0.0333. The lens is 300 millimeters, so it's going to be 300 squared, all divided by f, which is 2.8. Again, please don't forget to square if there's a square involved in your general equation. Okay, so now you just plug this in on your calculator. Again, if you have a CAS calculator, what you're going to want to do is you want to hit the control and then the divide button. So in that way you can access the fraction bar, so you'll get a little thing that looks like this. And you can plug these numbers in the numerator, plug the 2.8 the denominator, that way you can make sure you're getting the correct answer. If you don't have a CAS calculator, what you're going to want to do is you're going to want to simplify this piece by piece. You're going to want to first take 0.033 times 300 squared, write that answer down, and then divide that answer by 2.8. Do it in 2 separate steps, and you'll end up getting an answer then of 1,060.7, and this would be in meters. Okay, why don't you guys take a minute and do the next problem on your own. I'm going to actually stop the video here, though, so I can get this under 15 minutes. So watch the next video to be able to find your answer to this problem.